That is, not everything is possible, meaning that evolution is the manifestation of a fundamental nature. Considering randomness at the subatomic level, it has seemed probabilistically inconceivable that a product as complex as life, in that it requires exacting universal constants that must have been present or have come into being at the moment of the initial quantum fluctuations, could have arisen from a process that is inherently random. It would seem that there must have been instead a force or principle from without to guide the emergence of these constants toward this end. However, randomness is merely the manifestation of possibility. If all that is possible must occur in time, such as every possible variation of the quantum fluctuations, for instance, those that create the carbon molecule and those that do not, as is posited in the multiple universe theory in physics, then random variation simply secures the inevitability of the carbon molecule and of life as a manifestation of possibility. Or, if possibility, by virtue of its bounded nature, the boundary conditions, selects out what manifests from the initial quantum perturbations, then it drives both the activity of the manifesting of actuality and the nature of the manifest actuality. This is a process that would not require the heritable variations of multiple universes, and was described in Alan Turing's metamorphosis model, published in 1952, 2 years before his death, and 1 year before elaboration of the molecular model of DNA. Paraphrasing that model, one can give the analogy of a bowl of water resting stagnant. The inner rim of the bowl sets the boundary conditions of interacting wave patterns, setting motion by a single ripple on the water surface. The final pattern of ripples is determined by the boundary conditions fixed by the rim of the bowl. Possibility, therefore, is the teleological meaning of life. Not only is life not meaningless, it must be said to carry the deepest meaning as possibility manifesting. The myth of value judgment, a special problem arises for the classical myth of evolution with regard to the notion of value judgments. Classical evolution theory assumes that the products of evolution are random and therefore are without meaning. But consciousness has evolved as a search for standards that can stand on their own, and upon which one can make value judgments regarding truth, beauty, morality, aesthetics, etc. From the perspective of classical evolution theory, this search for independently valid standards would seem to be an illusion or a false hope. As Thomas Nagel pointed out, if the faculties that generate our value judgments are the result of natural selection, then the contents of consciousness would appear to suffer from the same meaninglessness. For there to be valid value judgments, either there must be an external, supranatural source of their origin, or the soup from which consciousness arises must itself render a meaningful teleology to both consciousness and its content. It is this latter condition that we find in the natural teleology of possibility theory. That is, consciousness is both manifest possibility and the perceiver of possibility. Therefore it can be understood as reaching into its own source, into possibility itself, for meaning. When one seeks for objective truths in science, one is seeking for what is possible. When one seeks for moral truths, one is asking about responsibility to perceived possibility. When one finds beauty, one is recognizing the manifesting of possibility. As the physicist Steven Weinberg surmised, the sense of beauty in physics, as in music, is the impression of inevitability. Sartre described human consciousness as a process of the mind reaching beyond itself at any one time and into open-ended possibility. In this quote, man is constantly outside of himself, in projecting himself, in losing himself outside of himself. He makes for man's existing, and on the other hand, it is by pursuing transcendent goals that he is able to exist. Man, being this state of passing beyond, and seizing upon things only as they bear upon this passing beyond, is at the heart, at the center of this passing beyond. Close quote. The notion of pre-existing value standards serves mythologically to facilitate the metaphorical grasp of open-ended possibility, that is, the creation of standard in terms of discovering them. This myth is the notion of value realism, described by Nagel as, in quotes, moral and evaluative truths that do not depend on our own beliefs. This search for independent values is the heuristic edifice that guides the metaphorical grasp of the conditions of possibility. The discovery myth seen historically. One can more easily observe the emergence of the discovery myth historically. For example, as we considered earlier, Elizabeth Patterson, in her account of the origin of the atomic theory of chemistry in the 18th century, described the initial reservations with the atomic hypothesis as, in quotes, a reluctance to accept as the elements of chemical combination any metaphysical entities, such as were atoms. Close quote. However, once the actions of various gases were explained by John Dalton in terms of their atomic weight, the atomic nature of chemistry appeared given as discovered. It was from this impression of discovery that the myth of discovery itself developed. That is, Dalton extrapolated from his experience of the given appearance of the metaphorical product by proclaiming that the purpose of scientific knowledge in general is the, in quotes, discovery of new and important facts, but much more when these facts lead to the establishment of general laws. Close quote. In this we observe that the appearance of the product, as discovered, spawned and sustained the discovery myth itself. Thereby the challenge to discover prompts the creative act of metaphor induction. Similarly, we have discussed the dialectical nature, whereby scientific knowledge grows through metaphor induction. Awareness of this dialectical nature threatens to expose the creative hand of the scientist, and thereby threatens the integrity of the discovery myth. The myth has evolved to ward off this threat by the manner in which it refers to the ongoing creative process. For instance, one does not refer to the dialectical process as the result of an incomplete metaphorical grasp of possibility. Rather, one asserts that the scientist merely has come up short, in that her observations are not sufficiently rigorous. That is, the winding road of scientific discovery is said to reside not in the perspectival nature of scientific knowledge, but in an incomplete perception of immovable objects. As Eddington said, we simply can and do call the resulting observation an, in quotes, bad observation. Close quote. This preserves the hypnotic appearance of the object as discovered. The scientist is sent back to the drawing board, and the medical student back to the patient. One indicts the observer for a less than rigorous observation, rather than acknowledging the metaphorical and thus inherently incomplete nature of observation itself. The resulting reformulation takes place in terms of a more rigorous observation of the given object. Similarly, the discovery myth handles the tectonic shift and root metaphor that we discussed in the previous chapter as a paradigm shift, simply with the claim that the objects populating a previous paradigm, such as elemental phlogiston, or the universal ether, or gravity as a force, in the traditional sense, simply never did really exist. Thereby the myth of discovery itself is salvaged. The limitations of positing a physical reality. As we have seen, the hypnotic feature of metaphor induction masks the metaphorical origin of the object. This results in a strict positivism that risks the denigration of other terms with which one might have more effectively grasped features of possibility. For instance, the 20th century behavioral psychologist, B.F. Skinner famously proposed that when describing behavior, it is better to avoid mentalistic terms, because, in quotes, the mind is nothing more than a manifestation of physiology. This exclusively physical cosmology led him to discount terms such as Herbert Spencer's life force, or Schopenhauer's blind will to exist, or Bergson's élan vital as a means of understanding human behavior. Even if it is true that a purely material, behavioral psychology is preferable for practical reasons, it still is the case that what will be said to count as a physical cause or as an objectively observed fact, or as the patient's material environmental history, is ultimately a formulation derived in response to the apprehension of possibility perceived in the doctor-patient relationship. That is, avoiding non-material terms in deference to physical reductionism does not spare one from the creative imperative. Furthermore, there may be features of human experience that are not amenable to the metaphorical boundaries of a physical cosmology. The physical does not represent the limits of the known, but the limits of knowing. The distinction between the medical decision as created versus discovered can be illustrated by looking at an early artifact of evidence-based medicine in the 20th century, called decision analysis. Consider this decision tree that represents the clinical decision whether to treat carotid artery occlusion with surgery or with medication. Each decision node in this decision tree is shown with its expected outcomes, weighted with their known probabilities and their subjective clinical utilities. Taking this diagram to represent the medical decision, the clinician can review the objective elements of the decision. As constructed, the structure of the decision tree appears given as evidentiary findings and data points that are independent of the clinician's input. The decision tree thereby appears as an objective guide for the clinician. The necessary outcomes of its causal links, as calculated, appear to establish the necessary truth of the conclusion. This illusion contributed to the creation of clinical computer decision tools in the late 20th century, into which the clinician was directed simply to type data based on prompts and to passively receive output that was calculated based on stored probabilities. One presumes that a computer tool based on such an algorithm can feed the correct decision to the clinician. However, there are two ways to view this diagram. One is to take its nodes to represent the decision points of the medical decision, as given. The other is to see in this decision tree a display of the metaphorical terms with which clinical possibility is contrived as nodes that make up the moments of the decision. This latter mythological perspective changes the tree diagram from a tool that makes the decision on behalf of the clinician into one that renders the tree as a tool with which to creatively modify the structure of the decision. It thereby renders the clinician aware of her responsibility to the underlying possibility that she seeks to grasp. In this fashion, it can serve as a tool for formulating the objective decision. But for this use, the computer must be programmed with a different kind of algorithm and user interface, one that facilitates the creative formulation of a decision tree in response to possibility apprehended in the doctor-patient interaction. The mythology of natural law. As we saw in the last chapter, the notion of natural law comes into being when a common route metaphor is applied to multiple areas of perceived possibility, where the same trajectory of intention can be made to apply. By accepting such laws as given, the subject is agreeing to structure the world within their finite terms. We noted that there are different kinds of laws. There are those that apply to specific trajectories of intention, such as the Pythagorean theorem, and those that apply to all instances of knowledge, because they grasp the contingencies of knowing a self. These latter are called the laws of nature, for they can be made to apply anywhere nature will be described. One such law of nature is Newton's first law of thermodynamics. This law of the conservation of energy was described by Eddington as emerging to accommodate the anthropic need for permanence, formulated in terms of the conservation of mass, or energy, or momentum, or electrical charge. In the 19th century, the notion of entropy became part of the study of thermodynamics. It can be thought of as the measure of disorder in a closed system. Entropy exists necessarily as a function of the perspective of the user, since order, and so disorder, are inherently perspectival. The user will insert the notion of entropy into a physical formulation by deciding ahead of time what counts as a closed system. A closed system being defined as that in which energy, as order, and disorder are preserved. In this way, the notion of entropy satisfies the anthropic need to define a system as a framework that permits a common basis of measurement. This is not to say that entropy does not exist, but that its existence is a function of the subject's perspective as the measuring entity. The notion of law functions as myth when we posit these laws as existing within the nature of reality, then formulate objects as if discovered to be adhering to these laws. Thereby, they become the set of root metaphors through which all of possibility is organized. As an example, we looked at how the metaphor of the triangle is used to grasp multiple areas where the same trajectory of intention can be made to apply in terms of the Pythagorean theorem. Similarly, we looked at how the metaphor of the diffusion of particles between chambers, formulated as Fick's law, can be made to apply to multiple areas of possibility, such as transfer the heat, electrical conduction, and population migration, in that these phenomena are amenable to this one trajectory of intention. Another example is the universal application of the method of calculus, since its development by Newton and Leibniz. This method at root is simply the formulation of diverse areas of possibility in terms of a common root metaphor. Any experience that is susceptible to analysis as a series of approximating intervals can, on that count, be reformulated geometrically as the area under a curve that is created by plotting these intervals as Cartesian coordinates on a graph. Thus, everywhere calculus is applied, possibility is grasped as the area under a curve. As David Hilbert famously said, in his axiomatic thought of, quote, "The art of mathematics is finding that special case that contains all the germs of generality," close quote. That is, the art of mathematics lies in applying a root metaphor within whose parameters the features of possibility can be grasped on a broad scale. We saw in the last chapter how the process of extrapolating metaphors to other areas of possibility is facilitated by their reduction to algebraic form. This reduction frees trajectory of intention from its metaphorical moorings. It permits the application of pure trajectory of intention to multiple areas of possibility, independent of the metaphor. Consider the Pythagorean theorem. By replacing the sides of a triangle with variables a, b, and c, one reduces their definition to mere distinction from one another, so that their grasped intention relative to one another may be referred to in isolation. Then, by representing their intentionality relative to each other with number, the mind is freed to extrapolate, not the metaphorical content itself, such as a triangle, but the interrelations of intention captured by the triangle. Likewise, this reduction to pure intentionality occurs in Fick's law of diffusion, by replacing particles in chambers with variables, then reducing their interactions to numerical relations. Thereby, other areas of possibility, as diverse as temperature change and population migration, can be construed and formulated in terms of these same intentional interactions. That is, it is not the metaphor that is extrapolated. Rather, the extrapolated element is the trajectory of intention, represented algebraically. For instance, this is why the rubric of harmony can be applied as an organizing notion to areas having nothing to do with musical sound. The mathematical form represents only the trajectory of intention, as it was applied in the original metaphor. As Eddington said, the fundamental laws, in quotes, are simply a mathematical formulation of the qualities of the parts into which our analysis has divided the universe. Close quote. The algebraic reduction is successful because of the mind's capacity to extrapolate from one situation to another at the level of pure intentionality. When applying a law to other areas of possibility, the user uses the metaphor only as a reference for orientation. This mathematical reduction of natural law became a hallmark of the scientific myth in the 16th century and coming to bloom with Newton. As Hegel said, Galileo and Descartes, in quotes, made the crucial conceptual division by proposing that physical science should provide a mathematically precise, quantitative description of an external reality. The myth of Western science therein evolved to posit a mathematical reality, wherein physical law was formulated as discovered therein. As Eddington said, quote, "Small wonder then that physical science should have evolved a conception of the world consisting of entities rigorously bound to one another by mathematical equations forming a deterministic scheme." Close quote. Intentionality as the origin of number. The need to refer to pure intentionality without regard to metaphor is the origin of number, and so of mathematics as the representation of number relations. That is, number refers to pure intentionality. The foundation of number lies not in the chosen metaphor, such as a geometrical figure, or the intensity of sound, or the mass of an object, or the rate of acceleration. Its foundation lies in the intention regarding possibility, harnessed by these metaphors. The number is a contentless formal representation of intention, stated in association with the manner of its measurement, such as the units of time, size, weight, speed, pattern, etc. Similarly, the basic functions of mathematics, in that they refer to number, refer to intentionality. As Eddington proposed, mathematical symbols, in quotes, represent elements of knowledge, not entities of the external world. Close quote. For instance, the function of equivalence represented by the equal sign means that two objects are the same from the perspective of intentionality.